Okay, students, and very happy to meet you again. In this topic, we are going to study about the generating function and counting principle. You might have, we might have surprised why I was discussing about the generating function. Am I correct? Why I explain generating function? You might have surprised. Why I explain generating function? Because there is a connection between a generating function and the counting principle. Already we have the counting principle in the second unit, counting principle. Am I correct? The product principle and the summation principle, like that. So when we compare the generating function with the counting principle, we have some idea connecting the coefficient of generating function and the counting principle, the counting of what can I say is that number of two taken at a time on the n elements, like that we can have some idea. Now look at that. Suppose that A0, A1, A2, all these are real numbers, be the sequence of real numbers. Then we know that we can make a generating function like this. How? I already told in the last video that x power 0 is multiplied with this A0, and A1 is multiplied by x power 1, A2 is multiplied by x square plus dot dot dot, AK is multiplied by x power k. Summate them, that's called generating function. That's what I was discussing in another video. Whether you remember this or not, I don't know. If you have not seen that particular video, you go back and then you view that, then only it would be easy for you to understand this. So A0 x power 0 plus A1 x power 1 plus A2 x power 2 plus dot 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 AK x power k. So that we can write in the short form, like summation form, like that. When k is equal to 0, you will get the first term A0 x power 0. When k takes 1, you will get A1 x power 1. When you take k3, you will get A3 x power 3, like that, dot dot dot. So that expansion is given in a short form like this. F of x equals summation k tends to 0 to infinity AK x power k. Now this I need not to say much about, because we know about that. I gave some examples also. But what is the speciality in that coefficients? I mean the sequence A0, A1, A2, A3, dot dot dot. The mathematical people found a significance between the coefficient of x power with the counting principle. Okay, I mean we know that what is A0. A0 is the first element. Am I correct? Yes. And the first element is 0 combination of a set with n elements. Suppose there are n elements are there. We are making a generating function like this. Then A0 implies the combination of a set with elements. 0 combination. So no combination at all. That number of combinations, 0 combinations out of n elements, definitely will be equal to A0. Now we know that what is the next element here. A in the next element means in the sequence A1. A1 in the generating function is nothing but one combination of a set with n elements. There are n elements out there. You are taking 1, 1, 1. How many times you can take? That is indicated by A1. Similarly, A2 implies two combination of a set with n elements. I mean, n elements are there. You are taking 2, 2, 2. How many times we can take? That is a2, the coefficient of x square. Very wonderful, is that not? So there's a connection between the sequence, the coefficient of the sequence of x power k, and the combination, number of combination occurring out of n elements. Similarly, if you go like that, you will have ak denote k combination of n elements. Ak, suppose 5. Out of n elements, we are taking 5, 5, 5 elements. How many times you can take? A 5 times. So just comparing the coefficient of the generating function, we can give the corresponding k combination out of n elements. It's a very wonderful wonderful creation or understanding from mathematical observation. Very interesting, is that not? Very interesting. So this is what we have to understand. So there is a connection between the generating function and counting principle. A0 denote 0 combination of n elements. A1 denote 1 combination of n elements. A2 denote 2 combination of n elements. That is number of 2 combinations out of n elements. Dot dot dot. AK implies k combination of n elements. Very interesting, is that not? Okay, with that I am coming to the end of this class. In the next class I will go to some derivations or conclusions from that. So thank you.